Hello and welcome to the second video in this series of my 8 kilowatt solar generator design. And for this particular second video, we're going to be talking about my design calculations. I always like to start with a picture of what the deliverable is going to look like, which is the end product. Yeah, so this is what we got, or what we are going to get at the end of this design series. Yeah, so like with every design that you're going to do in engineering, every design starts with a calculation. You have to calculate your load. You have to know what your equipment is going to be carrying. Yeah, and that is what this video is going to be about. It's going to be about us estimating what our loads are. If we get our load estimation correctly, your design is going to work like magic. I promise you that. Yeah. And what I'll be doing in this series is, after I finish with my own 8 kilowatt design, I'm going to be covering every scenario. Yeah, I'm going to be covering every scenario. If in your particular case you only have one light bulb, one refrigerator, one TV set, and you just want a solar system that is going to power just that, yeah, with the possibility that when you get more equipment, you are going to upgrade that your solar system, then I'm going to create different video series. It could be a 3 kilowatt solar generator design. I'm going to put everything here, and then just so everybody we have a design to work with. And at the end of each design, I'm going to have a summary page where I'll put the inverter rating or inverter capacity that we select for the particular load. If it's a 3 kilowatt unit solar generator, then I'm going to be recommending the solar the inverter that you're going to buy. So all you have to do is just to take that summary page, buy the inverter, buy the amount of solar panels and the capacity, buy your battery, and then you just call an installer to install. Yeah, again, I'm going to be explaining to you what the inclination angle of your solar panel is supposed to be, because if you for very sunny areas like countries in Africa and stuff where you have lots of sun, yeah, your inclination angle, yeah, your tilt angle, let me put it that way, your tilt angle, the tilt angle of your solar panel is not supposed to be more than 10 degrees. Yeah, ideally 6 to 8 degrees. Yeah, so, and that is for roofs that are almost flat. Nowadays you see roofs in Africa that are 45 degrees, which is actually meant for Western climate, where you have snow falling and all that. So, and also the angle of the sun is at 45 degrees is better for the Western world, not for places like Africa. For Africa, your roof, that the roof that is best for solar installation is supposed to be almost flat. That is why the optimal tilt angle for your solar panels is supposed to be around 0 to 10 degrees. Yeah. For my own installation, I used 8 degree, and the advantage of using that is, in Africa we have plenty of sun. Yeah, so trust me, from 7 o'clock in the morning, yeah, when the sun is just coming out, I have already started generating power, because you get the full blast of the sun when it's almost flat, like almost all through the day. Your solar panels will be will be producing electricity for you. Yeah, when you get your tilt angle correctly. So tilt angle, very, very important. So let's get on with, we digress there a little bit. Let's get back on track. So the video today is going to be about our load estimation, and because every design starts with a load calculation. Yeah, and again, to the right you see the deliverables that we're going to be getting at the end of the day. And yeah, so I just wanted you to see that, so you know what to expect. Yeah. Right. A quick disclaimer: the information shared in this video is for educational purposes only. While every effort has been made to ensure accuracy, you are responsible for your own solar system installation, because I'm not there. And this should be done by a qualified installer and must comply with local code standards and regulations. The creator assumes no responsibility for any loss, damage, or injury resulting from your own installation. Right. I'm just going to let you go through this. I've introduced myself in the first video. Let's jump right into our load estimation. Now, this is where it gets really, really crucial. If you get your load estimation correctly, you are going to enjoy your solar system. I guarantee you that. Now, one thing we're going to be doing with this whole series is that if your load is, it's almost like a mirror of my load. Yeah, I have loads from 1 to 9. If your load is mirrored to mine, yeah, just get an 8 kilowatt system. At the end of the video, at the end of the series, when I put all the all my recommendation on one page, you can just take a screenshot of it and then just go reproduce exactly what I did. Yeah. So for my load, yeah, I have about 3 freezers, 2 deep freezers and 1 fridge freezer. They are all they all run on very low, they're very efficient system refrigerators, so they run on like 100 watts each. I have an inverter AC 1.5 horsepower, which runs on 150 watts. I have a TV 100 watts, again efficient one. I have lots of lights, and they total about 400 watts. I have industrial fans. I think about 4 of them. This, what I mean by industrial fans, they are kind of like heavy duty fans, yeah. And each is about, I think each consumes about 150 watts, yeah. So I have a normal fan as well, 100 watts there, and then my borehole is a 1.5 horsepower. It has a 1.5 horsepower submersible pump, and it's running a power rating is about 1,100 watts. Yeah, so all these are all what I have, and then when you total all this power, you have a running power consumption of 3,550 watts. Yeah. So if it is running under normal condition, yeah, you get that. Yeah, when we're designing an inverter, then we're going to consider something else called peak power. Yeah. So because where you have compressors, electric motors, you get a starting surge. When you just start these equipment, you get a higher power rating than these ones that are stated here. So that is not going to have any at this stage of this load calculation. It's not going to have anything that has nothing to do here. But when we are now designing our inverter, when we are selecting our inverter or rating the inverter that we're going to need, yeah, that then plays a crucial role or a crucial part of it. So the next column here is the number of hours that I want these to run steady. Now, my intention or the thinking or the rationale behind selecting the number of hours is I intend to run like during the daytime when there is sunlight. Yeah, when we get to the point where we select or where we design the number of solar panels that we're going to need. Your solar panels will always, when you follow the right design, yeah, is always going to produce a lot more power, almost like 2 times. Your solar panels are designed to produce like 2 times the power, your running power. Yeah. So right now our running power is 3,550 watts. Yeah. So by the time we get to the point where we're selecting our solar panels, it's going to be almost like 6,000, 6,500, or even 7,000 watts capacity solar panels. Yeah. So what that means is during the daytime, when there's sunlight, yeah, so irradiation from the sun, you can power all this load and still have enough to be charging your battery. So during the daytime, you're not even going to be touching your battery. Yeah. That is why it's very crucial. So these number of hours here are just from 6 to 6 in the morning. That is what these are for. So it's for when you're consuming or discharging your batteries. Yeah. And then you have your energy, and then your energy per day, yeah, is just a product of the number of hours and your power consumption per unit, per component. Yeah. So for my deep freezer, I'll be needing 1200 watt hour of energy per day. And then when you sum all these up, you have a total watt hour requirement for the day for my system of 24,600 watt hour. Yeah. So I just want to emphasize that the first stage, which is load estimation or load calculation, if you get it right, yeah, all your system is going to work like magic. Is going you're all going to see exactly how this how my system performs, because after this design series concludes, I'll I'll be also giving you guys a follow up of how my system is performing, so you guys see, and we can all validate, yeah, our design with what we're getting in real life. Yeah. So again, I don't like making videos that are very long, so just so you don't get overloaded with information. Yeah. So I'm going to keep it short, I'm going to keep it concise, and I'm going to keep it to the point. Yeah. So I'll be ending the video here. If you have any questions, please get in touch with me. My email address was on the page where you have my name, the introduction, at the start of this video, the slide where I introduce myself. My email address is there. Get in touch. If you have particular design needs, just get in touch. Send me all your questions. Drop it in the comment section. Like, subscribe, so everybody can actually we can learn. We can learn together. Yeah. Share your experiences. If your load, like I said, are close to mine, just at the end of this design series, just take a screenshot of the summary page, where I'm going to be giving you guys a recommendation of what capacity of inverter, what capacity of battery, what total number of solar panel, what type, and capacity to buy. Just take a screenshot of it, and then just go buy this equipment yourself, because that's the only way we can cut costs. Getting solar panel, something that is feasible and possible by everybody, no matter your socioeconomic position. So thank you for watching. Subscribe, like, comment, share. Let's get this thing out to as many people as possible, because one of my aim of creating this channel is to solve the power problem that we have in Africa. And once you solve the power problem that you have in Africa, it's going to bring development to Africa, because the energy that you're supposed to be getting from the national grid, yeah, you are now producing your own. So that extra energy that the government will now have, they can send it to industries and companies and manufacturing facilities to boost their own production. Yeah. And then that will increase the GDP of each country in Africa. So this thing, it might look to you as if it's just something little. No, but it accumulates. It has a butterfly effect. By the time you have a lot more people being able to be self-sufficient in generating their own electricity, the power grid, the national grid, will have enough to send to companies for production, and the country, the economy of the countries, especially in Africa, will be greatly increased. So thank you. Subscribe, like, comment, and share, and I'll see you on the next one. Thank you.